So in order to understand about the image processing thing and object detection part, so let me just give you a glimpse to the back all the previous lectures that we had discussed today. So we have actually discussed about how to do like the image classification thing, right? Using a CNN library, and we know that how the CNN flow, the entire CNN flow works, right? We know other thing as well, right? We wanted if you really wanted to like do the classification part using a TensorFlow library, we have done that. Okay, we know that what is the like the distinction between the image classification, the object detection, and the image segmentation part, right? So these things we have already discussed before, right, in a very depth. Now before like moving it into the object detection part, I really wanted to like take you out from this today lecture is doing some little image processing part, okay, the image pre-processing part, because I see a lot of people, even the experienced one also, are like getting lagged in these kind of commonality thing, okay, because they actually don't know that how to like pre-process the image, how to do a very common operation on the image, like how to diminish the pixel size, how to do the image resizing operation, how to like convert the image into the byte, into the numpy, right, how to like cropping the image, how to like draw the bounding box over the image, how to draw the zone, how to like convert the image into the RGB format, GRB format, how to do the Gaussian blur. Okay, so other things, because like OpenCV libraries and Pillow libraries, which I'm going to discuss now, is going to help you a lot, right? You will feel much more confident about like doing the image processing thing by your own. Okay, and OpenCV, I will tell you that OpenCV is basically a kind of open source library or tool, okay, which is like coming up with the different image pre-processing classes and models and its own pre-trained many different libraries for doing the different tasks. Similarly, like when it comes to Pillow, so Pillow is basically a PyPower repository which helps you as a user to like do all these kind of a image pre-processing thing, okay, because these things are very vital, okay, in order to become a good image processing or computer vision engineer. So you need to have a command on how to do the image pre-processing thing by your own, right? So let me just move forward into the code, right? So I have already prepared a document for you, okay, so that you don't have to like worry about it, right? So these things are basically like, this is the common import which I'm supposed to do. So these are basically the import that I'm supposed to do, which is like the CV2, the version 2 of the computer, the OpenCV libraries. Then this is basically the NumPy for doing the NumPy operation. From the Pillow, I am supposed to import the image draw, the image font, and the image enhance. Okay, so these are basically the subclass. From this subclass, there will be many modules. Okay, I have picked up some modules just to show you that how all these things are actually working, right? Now from matplotlib is basically for plotting the image into the kernel. Okay, for request, so request is basically if the image is already in the URL link, so I will be like fetching the URL link into the physical file, right? Then again bytes IO for doing the bits and bytes operation. And when it comes to OS, so OS is basically like doing the common local directory changes and other thing. Okay, so let's try to load the image. Okay, so I will be loading the image from this response. If I really wanted to show you that response dot content, right? So as you can see that this is my image, right? And this is the image which is like already in the binary format. Okay, now if you really wanted to see this image, so you need to first decode the image, right? In order to decode the image, so I am supposed to use the first OpenCV libraries, which is like cv2.imdecode. Okay, so that my image is getting decoded from the high level to low level. Okay, so this is my decoded image. Okay, if I wanted to show you, right, image img. Okay, so this is my decoded image. Now you would definitely argue that this is not the image. Okay, so at the computer language term, so this is basically the image is already in the pixelated format, right? So if I just going to show you the image dot shape, right? So you would able to see that my, what is the shape? Now tell me. It is basically the three, which means that it has the three channel, which is like red, green, and blue, because these intermixing this channel you will be getting the colorful image. That is why these three channel you will see in every image. Okay, and for each channel the size of each image is basically 1080 is number of row and 810 is number of column. Okay, and in each row and column there will be a matrix. Okay, and each matrix there is a pixel range ranging from 0 to 255. Okay, that is why if I showed you this one, right, so image, right? So this is basically, let's say this is the first array is basically my red pixel, the second array is basically my green pixel, and the third array is basically my the blue pixel. Okay, similarly this is basically the entire thing, right? The entire thing is basically the set of array. Okay, set of array containing the information of the image into a pixelated format ranging from 0 to 255, right? And if you really wanted to see the image, right, so for that I am supposed to use this like the pillow libraries. Okay, so if I wanted to show you this image, that how does this image looks, right? So image.pill, right, this one. So this is my image is basically looking right. So this is like the all the combination of red, green and blue format, right? And if you wanted to save it, you can basically save it, right? So here you will see that I will be using, so from now I will be using this image which is like the class for imported from the pillow libraries. Okay, and inside I am calling one method which is like open, and inside it I will be using this bits.io for converting the binary encoded image into a physical file image, right? Now similarly the other part, now let's do the color conversion. Now when I say converting the color, so you will see that a lot of the image that you get, right, even as a raw data file or even like downloading it from the internet or somewhere else, right? So that may be already in the red, green, blue format, or that may be somewhere like into the black and white format. Okay, so you need to first do a kind of color conversion thing, okay, for your own use cases, right? So suppose that if I actually like taking the image from night vision camera, okay, then the kind of image that you will be getting, right? So that may not be in RGB format. So first of all, you need to convert into the RGB format, right? Similarly, let's say there has to be something called as in a very proper linear format. So somewhere you will be getting the red, green and blue channel arranged in a serialized manner, or some image you will be getting the blue is getting in the first, so blue, green and red in the other format. Okay, and let's say that red, then blue and then green. Okay, so this format you need to first serialize it, right? So that is why this color conversion is needed. That is why I'm supposed to use from the CV2, I'm supposed to call one method which is like CV2 color, so that this image, right, so this image is getting converted into, let's say first I'm going to convert it into the gray category. Okay, so if I just going to plot it, you will see it, right? So let me just use plt dot figure, right, and this one, right? So you can actually see that I have converted this image into the gray format, right? So this, as you can see, that color BGR is basically the BGR image is getting converted to gray format. Similarly, if you want to convert it into the RGB format, you can do that thing. If you convert it into the HSV format or in a like let's say bitlab format, you can actually convert it. So let me just show it to you. So it's just a OpenCV library that I'm not doing anything else. I'm just calling the method, that's it. So plt.figure, right? Similarly, if I wanted to like the other thing which I wanted to show is HSV, right? Similarly this one. So you will able to see there are a lot of variety of this image. Okay, this is basically the image which I am getting, original image which is like red, green and blue format. Okay, this is basically a pixelated image where like kind of segmented, so all these pixels are getting like submerged into the one category, then this pixel are like converted into the other category, because this may be a shadow, this may be an unshadow part, then like the color of this one has to be somewhere equal, something like this, right? See, you can see the dark color here and the dark color on the jacket. So these things like has been encoded into the one image cluster. Similarly for this one is converted into the another color. Okay, so like this color, and then let's say the upper region of this white color, okay, it's converted into the pink one, right? So in this way you would able to see the white color and the this part, right? So in this way you would able to like draw so many other case study from this image doing the pre-processing thing, okay, by converting the image. Now let's do the image cropping thing. Okay, so when it comes to the image resizing and cropping thing, so what does that mean, right? So it means that there's somewhere you might like the problem comes to you when like the image resizing operation has to be done, or let's say that from the image itself you wanted to crop some your own region of interest. Okay, you don't want the entire image, you wanted to just crop some part of the image. Okay, so first of all let's try to resize the image. Okay, so let me show you that what are the image I have. So after this, let's say that I have the image is something this one, right? So I have these many image, okay, and like if I just going to print the size of this image, so it will be these many size. You don't want that, okay? So what you're supposed to do is that you are again supposed to call from the pillow resized operation, okay? So this is basically from the, so let me, yeah, so this is like I am actually like first of all opening the image as a physical file, and if I just going to show you, right, the resized of size, right, so this is basically my original size of the image, right, and if I really wanted to like resize this image, so what I'm supposed to do is that I'm supposed to like do call resized underscore image, okay, equals to then this is my original size, right, so this is like the pre-resized image. I should write the pre-resized image, right, pre-resized image, right, this is my pre-resized image, right, and let's say that this is my the resized image, right, so I'm supposed to call this pre-resized image dot, let's say, resize. I'm going to like do the resized image as, let me print it. So now you can actually see that my big image is getting resized over 200 by 200 pixels. So let me just print the size as well. So you will see that my image is like converted from this size to a very proper size, which is like 200 by 200 pixels. Similarly, like if you wanted to like resize some other shape, you can actually do that thing. Now this is very important. See, whenever you wanted to crop this image, right, and I see a lot of ML practitioners, even the experienced one, right, they always try to do the image processing thing thinking that their image is basically like starting from the origin at the very left part. So suppose, but it actually it does not work. Okay, so the image has to be from the top left corner. Okay, so your top left has to be your origin. Okay, your top left has to be origin. It's not your like bottom left corner. Okay, so just forget about this. So in image processing it becomes opposite. Okay, so it has to be top left, so the origin has to be, so whatever the calculation that you're supposed to do, okay, suppose that if you wanted to like crop this part of the image, then you need to take this origin as a reference. Okay, that is why this origin has to be taken as a reference in order to do the image cropping part. And the cropping part is also very easy. First of all, again, you will be reading the image from the Pillow libraries using the image class. Okay, then this is basically the image, and if you really wanted to like crop the image, then you're supposed to call the crop method. Okay, crop method inside this Pillow library, so that the 100 pixel you are going to crop. Okay, you are going to crop the 100 pixel from the left side. Okay, then 100 pixel from, let's say, the right edge. Okay, similarly this is the right side of the edge and this is the bottom edge. Okay, and if you're supposed to do this thing, so you will be getting, so from this image you are actually cropped this image. So if I just show you this image, right, so from this big image your area of interest is only this part, so you really wanted to crop this part, this portion of the image, right, so that is why you have just cropped this portion of the image, right. Similarly, if you like wanted to do the cropping operation using the OpenCV library, you can actually supposed to do that thing. Okay, this is how we are actually cropping the image, right. Now let's do the filtering and detection operation. See, when it comes to filtering and detection operation, there are so many other way. Okay, so suppose that I wanted to like do a gray filter. Okay, so suppose the image contrast is very high. Okay, and it is taking so many space or processing time because the contrast is high, so the pixel value is high. Okay, so it means that it needs more numerical operation. So I don't want that. I want this image to get a little diminished. I want this image to make it little grayish in color. Okay, so that my processing part will take a lesser time, right. So for that I will be converting this image into a gray color. Okay, so similarly I'm supposed to use from the CV2, I'm supposed to use CV2 color. So CV2 is basically the thing, the computer, the OpenCV libraries which I have imported. From this I will be using the CV2 color as a method, and in this method I am going to pass the two things. The first thing is that I am supposed to pass one image as a physical file. The second thing is that I am going to pass the conversion, which means the color to, I am going to convert this BGR to gray format. Okay, in this way, so that if you see the image, right, so let me show you the image, that how does it looks like, right. So plt dot, let's say, figure, and see, so from this image, like it is getting converted into some kind of a grayish format, right. Similarly, like if you wanted to like blur some portion of the image, okay, so for blurring the image, let's say I'm supposed to use cv2 dot Gaussian blur. Okay, so that I wanted to like blur some part of the image, and this is basically the kernel size, right. So this is how you wanted to blur these portion of the image, right. So if you really wanted to like plot this blur picture, so first of all let me show you, right, because the blur is also an image. If I just go and just see the blur dot shape if I write. Okay, so it is also having an image into the RGB color, right? And if you wanted to plot this thing, so again plt dot figure and then figure size. So figure size, I'm supposed to use this one, and then I'm supposed to put this. So see, the image is getting blur here. Okay, and suppose if you wanted to increase this 21 to 31, so you will see a lot more blurring to this image, right? Why blurring is needed? Because in some portion, let's say you are getting a live streaming, right, and the image size is basically, let's say 420 by 420, and you wanted to blur only your cropped region. Okay, so you can actually try to use this. Okay, similarly, let's say that you wanted to like the some kind of a edge. Okay, and why it is actually needed is that, for example, let's say in a lot of medical research. Okay, I will give you my research paper, right, which is like published in the international journal. So what it happens is that, so my research was mostly like inclined towards the diabetic retinopathy. Okay, so you have the image of the retina, and the retina is basically having a very thin blood vessels. Okay, so like it is not able to like capture it from the real naked eye, right? So what you're supposed to do is that you're supposed to do some kind of a image pre-processing thing, right? So what I would personally found out when I was doing research here is that some portion of the image is basically blurred. Okay, some portion of the retina is blurred, some portion of the retina may have a very thin vessels. Okay, so and some portion may have a very thick vessels. Okay, and I wanted to study over the very thin blood vessels. Okay, the thin line. Okay, so that I could able to like segregate all the retina which having a very thin blood vessels into the one category. Okay, so how did I use that thing? So I actually like use this one, cv2.canny. Okay, so what does it do is that it basically like try to only detect the edges, right, from the image. Okay, so let's say that if I just going to put this one, right, and if I just going to plot it, this is edge. See, this have already detected some part of the edge. Okay, like by neglecting the other portion of the image. Similarly, let's say if you wanted to show you something else, blur region. See, okay, from the blur part it is able to like try to segregate only the edges which is actually like watchable from this. See, this is my blur image, right? And let's say that if I wanted to see this gray part, this is my Gaussian blur part. Okay, and from the blur part you are able to capture these many edges, whatever it is like needed. Okay, so in this way you would able to like take out the edges, right, from the image as well. Okay, so let's say that if the image, and it is like, I think it is mostly like used in a medical domain, and let's say it's very important. I would also tell you that in the semiconductor domain. Okay, so before like the image is going for a fabrication, okay, before going image is going for a fabrication, so you have a something called as the chip design architecture. Okay, and that is basically the image has been taken. Okay, and you really wanted to find out the cracks on this image. Okay, so how do you basically do that thing? You can just apply, you can do the image processing thing, and you can just apply this edge detection part, and you can actually study the edge, right? So because what happens is that, because before like going for a fabrication, okay, so all these things are basically designed in a so precise manner, okay, that finding out at the very atomic detail has to be a big challenge. Okay, so that is why there the big computer vision libraries comes into picture. Okay, so like it has to pass through a good CNN pre-trained architecture just to detect that is there any cracks in the chip or not. Okay, so from this is actually the one of those middle step, right, where you wanted to just find out the arrangement of the lines. Okay, the arrangement of the symmetricity. Okay, and if you find out that this line is basically not symmetric to the other line, so it may classified as in the category of crack versus non-crack. Okay, so you can basically try to like get the game glimpse from there. Okay, so that is why this is the very good application when it comes to like detecting the edge, so and then blurring and de-blurring the image, right, and then converting the image into the like the grayish format. Okay, or let's say let's say like I will also show you after this one that how do you actually like increase the brightness of the image. Okay, so let's say that you wanted to adjust this brightness, now where it is actually needed. Okay, so let's say that you're actually working as in the domain where the image is getting live streamed. Okay, so for example, if you're actually like working in a space origin, okay, or let's say your most preferable area of research is taking the image from the solar system. Okay, now the image that you are supposed to take, okay, some portion of the image is like very bright and some portion of the image is very blur. Okay, and let's say that from the brighter image, right, some portion of that brighter image you wanted to neglect it. Now there is two way, either you crop it or either you diminished some of those image. Or let's say that the image that you are getting, right, from the very night vision camera, that image containing lot more information, but because the image is so diminished that you could not able to like take out different case studies from it. So what you will do is that you will try to increase the pixel. Okay, I hope you get it right. You try to increase the pixel. So whatever the image you have, I already told you that these images are already in the pixelated format. Okay, so you will see that wherever my pixel is like less than 30 to 40, 20 to 30%, right, I will try to explicitly increase that pixel so that my image brightness will get increased, so that I can like get so many information from this captured image, right? So that is why image enhancer, okay, so image enhancer class comes into picture. Okay, so this one, so if you really wanted to like see these things, so let me show you one more thing. So this is my original image looks like. Okay, this is my original image looks like, and let's say that I wanted to increase the brightness of this image. Okay, so how can I actually increase the brightness? Similarly, I will be calling from the image, so from the pillow, okay, I will be calling the image enhancer as a subclass. From this subclass, I am actually calling a method. Inside this method, I am passing an image, right? Now, I'm just like locating, like I want the brightness to approx 1.5, okay? So the brightness region is like 1 to 10, right? So like, let's say that I wanted to like do the brightness. You can actually see the range. I'm not sure about what should be the range here, but like, let's say that I put the range as 1.5, okay? Now what does it do is that, let's say that if I just going to plot it, right? So you can see the brighter image. Okay, have you compare, see this image and then this image, right? Similarly, let's say that if you wanted to like make this image a little darker, okay, so what you will do is that you will just try to decrease this like 1.5 to let's say 0.5, and the same thing you're supposed to see, right? So let me just show it to you. This one, right? See, so it has to be dark. See, I've not done anything. See, enhancer dot enhance, okay, because enhancer is basically a sub module inside this the image enhancer class. Okay, so here if I just see, the image is getting dark here. Okay, now let's say that if I just going to 0.1, the image is much dark here. Okay, so in this way you can actually try to do the image enhancement, reducing the contrast of the image, like reducing like up, like increasing the brightness of the image. Okay, then like increasing the diminished portion of the image by your own case study. So similarly, let's say that if you wanted to like increase the brightness, so if you wanted to make a very high contrast image, you can actually use it, right? So I'm just supposed to use here high contrast. Okay, see, my image is getting contrasted in a very high pixelated format, right? So in this way. Now suppose like if you wanted to draw some kind of a bounding boxes, but before bounding boxes, I think I have already showed you, right, that how to crop the image, right? So let me give you one task. Okay, take out, I've already given you some kind of a this example of in the semiconductor domain, right? So you will be having so many image of, let's say, the chips. Okay, so what I want is that I want you to first of all try to gather this chip image. Okay, you will get a data from anywhere. Okay, and just try to segregate this chip image by using the edge detection. Okay, by using the edge detection from the CV2 library. Now how will you do that thing? You can actually apply so many things. First of all, you try to use the image cropping operation, but before using the cropping operation, let's say that you have a chip. So let me show you. Let's say that this is basically the some portion of your chip, the black region. Okay, and you have, let's say, 1,000 image, correct? Now with this chip, right, now what I want is that first of all try to use the CV2 edge detection, so that you will get the arrangement of the cracks. Okay, and wherever you will see, wherever you will find a pattern, because AI is all about finding the pattern. Okay, so wherever you are actually finding the pattern where you see a very disoriented design, okay, from the edge, so you try to classify it into the bad chip and a good chip. Okay, wherever you see that there is a disorientation, you try to classify into the bad chip folder and then good chip folder. Now once you actually do the classification part, okay, the next task for you is to do the image cropping thing, which means that wherever there is a disorientation of the edge, okay, you wanted to crop only that part, okay, rest you wanted to leave it. Okay, so you can just apply the image cropping operation, which I already told you. Okay, you can just take out the pixel calculation. You can just take out the pixel only this interested area, and you can actually try to crop the image, right? Similarly, you can do it by yourself, right? There are many different case studies in the industry that people are like doing it into just for the image processing part. I'm not telling you to like train the model, okay, I'm just telling you to do the image processing by yourself, so that you can, once you look after by your own work, then you will feel more confident that these processing things you have done by your own self from the very basic, okay, but just by using these OpenCV and Pillow libraries, right? Now let's try to use the this one. So bounding box, okay, so bounding box is nothing but it is just the area of interest. Okay, you wanted to like plot your own area of interest into that image, right? So for that you wanted to like draw the bounding box over this image. So again I am just calling the image draw. Okay, image draw is basically from the Pillow library. I'm going to pass the image, I'm going to draw the rectangle. I will be passing the two coordinate. Okay, so this is my the top left coordinate and this is my the bottom right coordinate, and these two coordinates are sufficient enough to like draw the bounding boxes. Okay, because see, this coordinate I have, this coordinate I have, can I able to find out this coordinate, right, by adding these two? Can I able to find out this coordinate by like subtracting these two, right? Because the x is actually the same, right? I just need to find out the y here. Similarly here I just need to find out the x and y, right? So in this way these things are actually internally do it by itself. Okay, so you don't need to do any pre-processing thing. Similarly, let's say that if I wanted to shift a bounding box a little above, okay, so let's say 300. Okay, so it will going to shift it above. I think this is actually more than enough just to give you a little glimpse about that how does image processing happen. Okay, so let me just revise the concept for you. Okay, so what you have understood from this video, you have know about how to load the image. Okay, then you have know about like how to convert the image into the RGB format, or let's say other than RGB format, whatever the image format you have. Okay, you know how to convert it into the RGB format using a CV2 library. Okay, then other thing is that you know how to crop the image. Okay, you know how to resize the image, correct? You know how to increase the brightness of the image, you know how to decrease the brightness of the image, right? You know how to do the gray scaling of the image. Okay, you know how to do the edge detection of the image, not the edge detection, like you wanted to like define the edge, okay, from this very contrastive image you wanted to like take out the edges, okay, for your own case study. You already know this thing. Okay, so these things are very basic libraries, which is I think more than enough, okay, to actually like make yourself a good image processing / computer vision engineer. Okay, so image draw, you know, image font, you know, image enhance, you know, right, and whatever the things that I've already loaded. Okay, I will actually share this entire notebook, right, so that you can actually try it by yourself. Even like if you Google it out and do the chat GPT, you will get a lot more different very interesting libraries. You can actually ping it before like in below, and actually do let me know that what are the other interesting image pre-processing libraries that you actually find it out, right? So you know about all these things. So this is just a basic glimpse just to let you know that how good the image processing is needed. Okay, how like really it is needed in an industry, right? So that next we carry forward to our again the same lecture. We will going to do the image detection, object detection part, then the training part, then let's say the visualize the training part, right? And other thing we are going to do so many exciting things above like from this. Okay, so this is just 2 or 3% I wanted to show you. Okay, thank you.